Hi students, in this video, I am going to explain some questions, important questions according to board exam CBSE Trigonometry Chapter 8. Okay, so here the first question is if cos A plus cos square A is equal to 1 they have given. So now I am going to transpose this cos square A towards RHS side. So it will become 1 minus cos square A. So now they are asking us to find the value of sine square A plus sine power 4A. Okay. So now what I am going to do is, see the first one is sine square A. Okay. Plus sine power 4A is written as sine square A into sine square A. Is it clear students? So here sine square A I am going to write like this only plus, and in the second term sine square A can be written as 1 minus cos square A. Did you understand students? See, we know the identity, trigonometric identity, sine square A plus cos square A is equal to 1. Is it clear students? Now I am going to transpose cos square A towards RHS side. It will become 1 minus cos square A. So this one we got from our trigonometric identities. Is it clear students? Now sine square A, another sine square A also I am going to write as 1 minus cos square A. Understood? So next the first term is sine square A plus, so from the given data we have 1 minus cos square A is equal to cos A. Did you understand students? So in place of 1 minus cos square A, I am going to write cos A into cos A. Understood? So the first term is sine square A plus the second term is cos A into cos A gives how much? Cos square A. Is it clear students? Now we know the identity sine square A plus cos square A is equal to 1. So this value is 1. So simply we can write as sine square A plus sine power 4A is equal to 1. Did you understand students? Students, the next question is, we have tan of a plus b is equal to root 3 and tan of a minus b is equal to 1 by root 3. Okay. So they are asking us to find the values of a and b. Is it clear students? So tan of a plus b is given as root 3. Okay. So from this we know that tan of a plus b is equal to, we know that tan 60 degrees gives root 3. So in place of root 3, I am going to write tan 60. So LHS and RHS tan will be cancelled out. So A plus B will be equal to 60 degrees. This is equation number 1 students. Okay. So the next data what they have given is tan of A minus B is equal to 1 by root 3. Clear? So tan of A minus B will be equal to, so 1 by root 3 is nothing but tan 30 degrees. So the value of tan 30 is 1 by root 3, cancel tan on both sides. We will get A minus B is equal to 30 degrees. This is equation number 2. Okay. So in order to get the values of A and B, I am going to add equations 1 and 2. Clear students? So how to add? A plus B plus A minus B will be equal to 60 degrees plus 30 degrees. Is it clear students? Now plus B and minus B value is 0. A plus A gives 2A, that is equal to 90 degrees. Okay. So therefore the value of A is equal to 90 divided by 2, that is equal to 45 degrees. So apply A value in any of the equation 1 and 2 and find the value of B students. Clear? So we have A plus B is equal to 60 degrees. So the value of A is 45 degrees plus B is equal to 60 degrees. So transpose 45 towards RHS side, 60 degrees minus 45 degrees. Okay. So the value of B will be equal to 60 minus 45. How much students? 15 degrees. Understood? So the value of A is 45 degrees and value of B is 15 degrees. Clear? So here our condition is also satisfied. They have told in question A should be greater than B. Yes, A is greater than B. Did you understand, students? Students, the next question is, so evaluate. So here they have given tan square 60 plus 4 sin square 45 plus 3 secant square 60 plus 5 cos square 90 whole divided by cosecant 30 degrees plus secant 60 degrees minus cot square 30 degrees. So in order to find its value, we have to know the values. So what is the value of tan 60, students? Root 3. Okay. So root 3, here square is there, whole square plus 4 into the value of sine 45 is 1 by root 2. Okay. Whole square plus 3 into secant square 60 degrees. What is the value of secant 60? 2 whole square plus 5 into cos square 90 degrees. What is the value of cos 90, students? 0. Okay. Whole square whole divided by, so cosecant 30. Okay, so reciprocal of sine 30, you can write here sine 30 is 1 by 2 and cosecant 30 is 2 plus secant 60 degrees. This is also 2 minus cot 30 degrees. So okay, cot 30 is root 3 and whole square is there. Is it clear? Now we are going to find the value of this. Okay, root 3 square is 3 plus 4 into 1 by root 2 whole square. 1 square is 1, root 2 whole square is 2 plus 3 into 2 square is 4 plus 5 into 0 is 0. Understood? By 2 plus 2 is 4, students, minus root 3 whole square is 3. Okay. So very simple, students. Here we are having in the numerator 3 plus, so 4 divided by 2. 2 ones are 2, 2 twos are 4. 2 plus 4 into 3. 12 plus 0 whole divided by 4 minus 3 is 1. Understood, students? Next, 3 plus 2 is 5. 5 plus 12 is 17. 17 plus 0 gives 17 and 17 by 1 gives 17. Okay, so the value is 17. Understood, students? Students, the next question is, if 4 cot square 45 degrees minus secant square 60 degrees plus sine square 60 degrees plus p is equal to 3 by 4. Then find the value of p. Okay, find the value of p. Okay. So now we know the values. So cot 45 degrees, how much, students? 1. And secant 60 degrees, how much? 2. And sine 60 degrees, how much, students? Root 3 by 2. Now we have to apply these values here and find the value of p. So 4 into 1 square minus 2 square plus root 3 by 2 whole square, sine square 60 degrees now, plus p is equal to 3 by 4. Okay. So 4 into 1 square gives 4 minus 2 square is 4 plus root 3 by 2 whole square. Root 3 whole square is 3, 2 square is 4 plus p is equal to 3 by 4. So the value of plus 4 and minus 4 is 0, students. Now transpose this plus 3 by 4 towards RHS side. Already here 3 by 4 is there, plus 3 by 4 after transposing becomes minus 3 by 4. Okay. So plus 3 by 4 and minus 3 by 4, the value becomes 0 now. So p is equal to 0. Okay. Understood, students? Students, the next question is 1 plus sine theta. So I'm going to take LHS first. So 1 plus sine theta by 1 minus sine theta minus of 1 minus sine theta by 1 plus sine theta is equal to 4 tan theta secant theta. So now I have taken LHS, and what I am going to do is I am going to take LCM. So in the denominator we have 1 minus sine theta and 1 plus sine theta, multiply in the denominator, this is the LCM, and in the numerator, so first term denominator we have 1 minus sine theta, we don't have 1 plus sine theta in the denominator of the first term. So multiply this with the numerator. So 1 plus sine theta into 1 plus sine theta gives 1 plus sine theta whole square minus, in the same way, if you apply the fraction concept here, so the second term will be 1 minus sine theta whole square. Understood, students? So we know the identities, algebraic identities. A plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. So we are going to apply these identities in our numerator. So 1 plus sine theta whole square means 1 square is 1 plus 2 sine theta into 1 gives 2 sine theta plus sine square theta minus. So here minus is there, use brackets here because we are getting 3 terms here. Okay. So 1 minus sine theta whole square is 1 square is 1 minus 2 sine theta into 1 gives 2 sine theta plus sine square theta. So we have applied the identities here, students. So in the denominator we have 1 minus sine theta into 1 plus sine theta. So be careful while applying the identities, students. Okay. So now I am going to remove the bracket here. So 1 plus 2 sine theta plus sine square theta. So minus 1 plus 2 sine theta minus sine square theta. Understood? How did we get these signs? So we have to write, if we have negative sign before a bracket, write the additive inverse of all the terms inside the bracket. Understood? Now in the denominator we have 1 minus sine theta into 1 plus sine theta. So the third identity is a square minus b square, that is equal to a plus b into a minus b. This identity we are going to apply in the denominator. So this becomes 1 square minus 1 square is 1 minus sine square theta. Understood? So what we have to do here? And another trigonometric identity we are using here, sine square theta plus cos square theta is equal to 1. So now I am transposing this sine square theta towards RHS. So what this identity will become? Cos square theta is equal to 1 minus sine square theta. So in the denominator we have 1 minus sine square theta. In place of that I am going to write cos square theta. And coming to numerator, so many like terms are there here. So plus 1 and minus 1 gives the value as 0. Okay, so 2 sine theta plus 2 sine theta gives 4 sine theta, right? Next, sine square theta minus sine square theta, its value becomes 0. Okay, and in the denominator we have 1 minus sine square theta gives cos square theta. Okay, now what I am going to do is, I am going to write this as 4 into, I am writing this cos square theta as cos theta into cos theta. So 1 by cos theta into sin theta by cos theta. Understood, students? Okay, so the next part I am going to write here. So that is equal to LHS is equal to how much? So 4 into, so 1 by cos theta is nothing but secant theta into sin theta by cos theta gives tan theta. So the 4 into secant theta into tan theta is nothing but our RHS, students. Therefore, we have taken LHS and we got the answer what is there in the place of RHS. Is it clear? Students, the next question is proving, students. So what we have to prove is cos square theta by 1 minus tan theta. So what I am going to do is, first you take LHS. So LHS they have given cos square theta by 1 minus tan theta plus sin cube theta by sin theta minus cos theta. Clear, students? So this one we have to prove 1 plus sin theta cos theta. Okay. So I am going to take LHS. So in order to prove this, first we have to write the basic identities. Okay. So here the identities required are a minus b whole square is equal to a square minus 2ab plus b square. And the another thing is, one is a minus b whole cube. So the formula is a cube minus b cube minus 3ab into a minus b. Understood, students? So now I want the value of a cube minus b cube. So what I am going to do is minus 3ab. This term I am going to transpose this side. So it becomes a minus b whole cube plus 3ab into a minus b. Okay, that will be equal to a cube minus b cube. Clear, students? So these two identities we are going to use in our proving part. So LHS will be equal to, so here what I am going to do is this tan theta I am going to convert, okay. So cos square theta by 1 minus tan theta in terms of sin theta and cos theta is sin theta by cos theta. Clear? Plus sin cube theta by sin theta minus cos theta. So in the denominator, I am going to take LCM, students, that is equal to cos square theta whole divided by, here the LCM is cos theta. In the numerator, you will have cos theta minus sin theta. Clear? Plus sin cube theta by sin theta minus cos theta. Very, very easy, students. Okay. So now what I am going to do is, so this denominator cos theta will go to numerator. So cos square theta into cos theta whole divided by cos theta minus sin theta. Understood? Plus sin cube theta by sin theta minus cos theta. Understood, students? Now cos square theta into cos theta gives cos cube theta by cos theta minus sin theta. And here what I am going to do is, see, in order to equalize the denominators, see in the second term, I am going to take out one negative sign. Okay. So sin cube theta by denominator I have taken one negative. So cos theta minus sin theta we will get. So why I have done is to solve easily, I have made equalize the denominators. Okay. So now find the LCM again. So the LCM is cos theta minus sin theta. So what will be there in the numerator? Cos cube theta minus sin cube theta. Understood? Okay, students. So cos cube theta minus sin cube theta. Now you apply the identity. What is the identity, students? A cube minus b cube formula, a minus b whole cube plus 3ab into a minus b. Understood? So I am going to do here, students. So that is equal to cos theta minus sin theta into what I have to write here? Whole cube plus 3 into a. What is a? Cos theta. Cos theta is there in place of a and sin theta is there in place of b. Okay. Into cos theta minus sin theta. Understood, students? Just be careful while applying the formulas. That's it. So in denominator we have cos theta minus sin theta. That one I am writing in the denominator. Understood? And if you observe carefully in the numerator, you have two terms, only two terms. In that cos theta minus sin theta is common for both the terms. So I am taking it out. Okay. So what will be the remaining part in the numerator? So cos theta minus sin theta whole square plus 3 cos theta sin theta. Understood? Whole divided by cos theta minus sin theta. Clear, students? So in the numerator one cos theta minus sin theta is there. In denominator also one cos theta minus sin theta is there. It gets cancelled out by one time. Okay. In the numerator you have cos theta minus sin theta whole square. This is like a minus b whole square. What is the formula? So apply the formula. In place of A, cos theta is there. In place of B, sin theta is there. So cos square theta minus 2 sin theta cos theta plus sin square theta plus 3 cos theta sin theta. Understood, students? So in the denominator we have 1, no need to write that. So now what I am going to do is rearranging the terms. I am going to rearrange the terms. Okay. So cos square theta plus sin square theta minus 2 sin theta cos theta plus 3 cos theta sin theta. Understood? So last two terms are like terms. And we know the identity. Sin square theta plus cos square theta is equal to 1. So apply the identity here. Minus 2 plus 3, how much? Plus 1. 1 sin theta cos theta. So this is nothing but our RHS, students, isn't it? So what they are going to prove? They are asking us to prove 1 plus sin theta cos theta. Okay, that's what we got here. Therefore, we can write LHS is equal to RHS. Did you understand, students? Students, the next question is prove that sin theta. So I'm going to write the LHS first. So sin theta by 1 plus cos theta plus 1 plus cos theta by sin theta. Okay, this one we have to prove as 2 cosecant theta. Understood? So I'm going to take LHS and prove to RHS. Okay, so here what I'm going to do is we have to take the LCM first. So LCM means how much? 1 plus cos theta into sin theta. So be careful while writing the numerator. Here 1 plus cos theta is there in the denominator. So sin theta is not there in the denominator of the first term. So multiply this with its numerator. So sin theta into sin theta gives sin square theta plus the second term denominator is sin theta. We are not having 1 plus cos theta. So multiply this 1 plus cos theta with its numerator. Okay. This becomes 1 plus cos theta whole square. Understood, students? So now here numerator we have sin square theta plus, so 1 plus cos square theta, we know the first identity, algebraic identity, a plus b whole square is equal to a square plus 2ab plus b square. Understood? So in place of a 1 is there and in place of b cos theta is there. Apply here, students. So 1 square gives 1 plus 2 into 1 into cos theta gives 2 cos theta plus cos square theta. Understood? Whole divided by 1 plus cos theta into sin theta. Understood? So we know the trigonometric identity sin square theta plus cos square theta is equal to 1. So apply this in the numerator, students. So this sin square theta plus cos square theta gives 1. So 1 plus the second term is 1 plus 2 cos theta is there. Okay. In the denominator we have 1 plus cos theta into sin theta. Understood, students? So next in the numerator what we are having? So 1 plus 1 gives 2. So 2 plus 2 cos theta by 1 plus cos theta into sin theta is there in the denominator. So in the numerator I am having 2 common, take it out. So first term will become 1 and second term will be having only cos theta. And the denominator we are having already 1 plus cos theta into sin theta. If you observe carefully, numerator 1 plus cos theta and denominator 1 plus cos theta gets cancelled out for one time. So the remaining in the numerator is 2 by sin theta. So 2 into 1 by sin theta means 1 by sin theta is nothing but 2 cosecant theta. Understood, students? Therefore, if we take LHS, we got the answer as we are having in the RHS. So this is proved here. Understood, students?